Hello everyone. In this video, we will be factoring polynomial function using synthetic division. Before we jump into this example right here, let's have a review on roots or zeros of a function. Zeros or roots of a function are values of x that causes the function to be equal to 0. Now, there are some notations how roots are written in some problems. So in some problems, they write it this way. The roots are 5, -3, 2i, 3 plus minus I. In some problems as well, they write it differently. So they write like x is equal to 5. They also write this as x is equal to -3, x is equal to 2i, and x is equal to 3 plus I. And then this is also the other one, since it's plus and minus, so that would also be x is equal to 3 minus I. Now, if we want to change these roots here into its factored form, we are going to use the zero product property backwards. So we can go ahead and rewrite this as x minus 5 in parentheses, which means that if we equal this to 0, then we add 5 from both sides plus 5 from both sides. That's how we got x is equal to 5. So pretty much we switch the sign of this, and that would be in factored form. So in this next root right here, we can go ahead and write this as x plus 3. And this one right here can be written as x minus 2i. And this one right here in factored form, we can write this as x minus 3 plus I. And then that's the other one here is x minus 3 minus I. So this is how we change the roots into its factored form. So pretty much the trick is, if we are given the roots in either of these notation, all we need to do is to switch the sign of the root, put it next to the x, and put these two binomial inside the parentheses. Okay, going back to the example right here, since the highest exponent is 4, it means that there are 4 factors for this polynomial function. Okay, so our task is to determine what are these factors so that when we multiply these 4, it's going to come out to this. So the first step in order that we can determine the factors for this is to determine all the possible roots using the rational zero theorem. So this is our P and this is our Q. So we're supposed to find all the factors of P and all the factors of Q. So I'm just going to show the work right here. Okay, so what I did was I need to figure out what are the factors of P, which is 4, and what are the factors of Q, which is 2. So I'm just going to write the factors right here. So what I'm going to do is first I am going to pair up the 1 and 1. And then 1 and 2. So then we can go ahead and write the possible roots are... So it's going to be plus minus 1, and then positive negative 1/2. And then after that, we are going to pair up the 2 with the 1 and then the 2 with the 2. So this would come out plus minus 2 over 1 would just be a positive -2, and then we have a positive -2 over 2 is just plus minus 1, so we don't need to write that. And then I go ahead and pair up the 4 with the 2 and 1 as well, so 4 and 2 right there. So this would come out plus minus 4, and then 4 over 2 would just be a plus minus 2, so I don't need to write it. So these are the possible roots. Now our next step is to use synthetic division to test which one of these are factors. So I'm just gonna show the work right here. So I will use synthetic division. I will have to test each one of these. So the first one that we're going to test would be... Okay, so we need to figure out, is x plus 1 a factor? If it's not, then we move on to x minus 1. And then there's a trick here. We are going to test the whole number first, or the integer. So after we're done with the minus 1, then we go x plus 2 and x minus 2, and then x plus 4, x minus 4. If it doesn't work, we can go back to the 1/2. So but for now, we start with the x plus 1. Is it a factor? So we're going to use the synthetic division for this. So I'm just gonna write the coefficients right here. Okay, so once we're done with this, we're dividing this with a -1, because again, remember, we're going to switch this, so that would be a -1, or we're going to use the zero product property. That would be x plus 1 equals 0, so subtract 1 from both sides, so we go ahead and say -1. Or the fastest way is to switch the sign of this and then divide it. So in this case right here, we can go ahead and use the synthetic division. So we bring this down, so this would come out 2. And then remember, we're going to multiply these two. -1 times 2 is a -2. Then I'm going to write that up here. So this is a -2, and we add these two together. So this would come out 1. And we repeat the process. -1 times 1 is a -1. So I'm going to write that up here. So this is a -1, and then add these two together. So that's a -8. And then we repeat the process. -1 times -8 is a +8. And that's the one that I will write here. So this is a +8. And then we add these two together. So this would be a -4. And then we multiply -1 times -4 is a +4. And we write that up here. So this is 4. And we add these two together. And the remainder is 0. Since the remainder is 0, we can go ahead and say that x plus 1 is a factor. X plus 1 is a factor. So I can go ahead and write x plus 1 right here. Okay, going back to this, we remember that we are going to write the quotient for this after we divided it with x plus 1. We remember that since this is raised to the power 4, this means this is x to the third, x to the second, and x, and that's a constant. So then we can go ahead and say that the quotient is and this is the one that we're going to use in order that we can determine the rest of the factors. So what I would do is, since we're done with x plus 1, we're moving on to x minus 1. So I'm just going to use a different paper for that one. So okay, in order that we can test if x minus 1 is a factor, we're going to use synthetic division. So these are the ones that we write. So since we already have found out that x plus 1 was a factor, and then once we divided it, this was the quotient, so we're going to use this coefficients. So that would be 2, 1, and then -8 and -4. And this one shall be divided by a +1, since remember we just switched this, or we used the zero product property. And then that should be a +1. And then we will use synthetic division to determine if x minus 1 is a factor. Okay, since we got a -9 as a remainder, we can go ahead and say that x minus 1 is not a factor. Again, we remember that it's only a factor if the remainder is 0. Since this is not 0, we go ahead and say that x is not a factor. So we can't write x minus 1 over here since it's not a factor. So we are done with x plus 1, it was a factor, and then x minus 1 was not a factor, so I'm just gonna put that on the side. Now we are going to move on to x plus 2. Is it a factor? Again, we skip the fraction first, we do all the whole numbers. So I'm just gonna write it up here. In order to do this, we are going to use again this one right here, this coefficient. Okay, since we get a remainder of 0, we can go ahead and say that x plus 2 is a factor. And then the quotient would be, since this is to the third power, this means that this is to the second power. Since we are now on the second degree, we need to move on to the third and the last step. When you get to the second degree, use either the box and diamond or the quadratic formula to factor. So that means we are going to use the box and diamond in order that we can factor this. Okay, using the box and diamond, we determined that the other factors are this one. So first we have to write the other one right here was so we did the x plus 1, so that's written in there. The second factor was x plus 2, so I can go ahead and write that up here. That's x plus 2. So the next factor would be x minus 2, and the other one and the last one right here is 2x plus 1. So these have been all the different factors. I'm gonna write them in, I'm gonna circle them in blue. So this is in factored form now. So this is factored form. So this one right here is in general form, and this one right here is in factored form. Now, if we want the roots for this, we can go ahead and say that our roots are x is equal to -1, because we have to switch it. We use the zero property to solve for x, and the other root right here is x is equal to -2. And then the other root is x is equal to +2. And the last root right here is x is equal to -1/2. Now, if you check all of these roots, they are actually part of the possible roots here. So starting with a -1, so we have a -1, -2, we have a -2 right here. And then a +2 is part of that. And then we have a -1/2 is also part of these. That's it. If you found this video helpful, hit like and subscribe for more math videos. See ya!